Hello everyone, welcome back to my channel, and today we're going to continue another room of try me attacking and defending AWS services. In today's topic, we're going to over AWS IAM initial access, meaning that we'll be performing some exploit to gain initial access to the cloud environment via IAM principles. Okay, defining initial access in the cloud. In this room, you will learn about several different vectors for attackers to gain initial access to an AWS environment. Now, it is important to establish the outset that what we mean by initial access in AWS and in other cloud providers. Commonly, initial access is associated with compromising a computer system. It is also commonly associated with compromising user credentials. In the case of AWS, it is the second association that we are going to examine. While there are some peculiarities to systems deployed in AWS that attackers want to be aware of, the primary mechanisms of access in AWS is the credentials associated with the AWS IAM service. Compromising those credentials or the system contain them, and the method of accessing AWS services and resources. The learning objectives is we are going to take a look at 4 common techniques for getting initial access to AWS. 2 of those techniques we'll discuss theoretically, and 2 of those techniques we'll perform hands-on. Scenario we'll cover include Scenario 1, leaked credentials, Scenario 2, phishing for Stacksets, Scenario 3, SSRF to IMDS instant profile credentials, and Scenario 4, vulnerable automation. The learner should have a good grasp of AWS IAM before starting this room. If you need a refresher, please check out the IAM module before proceeding. Answer the questions. What is the primary mechanism of accessing AWS? Is IAM credentials? Yep. Accessing the environment, I'll skip this one as you may have known how to do it at this point. Scenario 1, found credentials in source code. We can't talk for long about AWS customer security incidents without discussing leaked AWS credentials. These credentials are leaked in a variety of sources, but one common theme you will hear over and over again is Git repositories. For over a decade, developers have been pushing AWS credentials and specifically long-lived IAM user credentials to GitHub and other public hosts of Git repositories. As development credentials are often highly privileged in order to create, update, and delete resources. These credentials can prove to be a goldmine for attackers who are fortunate enough to find them. So, why do developers keep doing that? Well, developers often use hard-coded credentials in scripts, or maybe the developer had credentials in a configuration file and forgot to add the configuration file to their .gitignore configuration, which, if you aren't familiar with, .gitignore file is a file that defines the files that should not be uploaded to a Git repository. These are a couple of common scenarios where developers may leave credentials exposed publicly. Even worse, developers may copy a work-related Git repository from a personal GitHub account so they can work on it outside of the provided corporate laptop or VM. In such cases, the developer often accidentally brings over the credentials when cloning the files from the private repository. Now, this problem is pervasive and significant that AWS proactively scans public GitHub repositories and quarantines leaked access keys. This mitigation has reduced the previous waterfall of credentials to trickle. However, there are still cases where the configuration of files and Git repositories may allow public leaked credentials to go unidentified. Furthermore, if you ever get access to private GitHub repositories, they aren't subject to scanning and are free game for finding such credentials. Open source tools such as Trufflehawk and Secret Scanner help attackers identify these credentials when scavenging files from various sources. In addition, programming language package repositories have been identified as a common source of leaked credentials. Given the sensitivity of open source software packages and supply chain security, it is safe to say those credentials might be important. There are certainly other sources beyond GitHub and Pipeline where you will find leaked credentials. Credentials might be lurking in many places, as we'll see in later scenario. we won't be performing a scenario where we find leaked credentials, but leaked credentials are something you want to remain cognizant as you perform AWS security testing. Answer the question. What files should prevent files from being included when they are uploaded to a remote Git repository? That's the .git ignore file. Alright, moving on to scenario number 2, phishing for Stacksets. In this task, we'll discuss a phishing scenario that demonstrates how an AWS account can be compromised via infrastructure as code, or known as IAC. AWS CloudFormation has a launch stack URL feature, which allows a user to deploy infrastructure with a few clicks. The launch stack URL uses the following context. Okay, it uses the console AWS, Amazon.com, CloudFormation's home, and then it'll specify the region, the stack or with the stack name, and then the template URL of the, so basically the CloudFormation template used for the stack. Okay, note that the following parameters can be set in the launch stack URL in order to redirect a user to deploy a specific CloudFormation template. Region is the region where the CloudFormation stack will be created. Stack name is the name of the stack that is used as an identifier for deployment. And template location, the URL of the template file. This can be a URL hosted on a Amazon S3. So, for example, the launch stack URL called by TryHackMe in the US1 region with a template hosted on Amazon S3 can look like this. Okay, so we have the region is US is 1, and then the stack name is TryHackMe. The template URL is the URL to Amazon S3 buckets, whose name is bucket name, and then the name of the template is the template name.template. Okay, per AWS, anyone who follows that URL is directed to the create stack wizard in the AWS CloudFormation console with the specified stack name and template location, as shown in the following screenshot. Users can still specify parameters and other stacks options. If they are not already authenticated, users are directed to AWS Management Console sign-in page and then redirected to the AWS CloudFormation Create Stack Wizard. In order for a potentially malicious actor to put the launch stack to good use, a phishing email can be carefully crafted in order to prompt a user to click on the link and deploy resources in the AWS account. Unfortunately, there are a few caveats that make it somewhat tricky to successfully execute this attack. 1. Phishing for Stacksets will only work against someone with the appropriate permissions in AWS. You will need to trick someone with administrative permissions. Number 2. Convincing an administrator to run a Stackset rely heavily on them not understanding what that Stackset is and being willing to run it anyway, or trust the sender, or it will need to appear sufficiently legitimate to pass the scrutiny of the administrator. And number 3, Stacksets that deploy IAM resources, like resources of primary value privilege escalation, require the administrator to assert special privileges known as capability_IAM and or capability_name IAM. These privileges are common in CloudFormation, but may raise red flags to targeted victim. So what CloudFormation resource can be used for phishing AWS administrator Stacksets? Right, moving on to the third scenario. Scenario number 3, SSRF to IMDS abuse. One of the most plausible and even common security issues that lead to attackers gaining access to AWS accounts is the abuse of EC2 IMDS. IMDS stands for Instant Metadata Service and is a service running on the EC2 instance that can be queried for standard configurations information on the instance. For example, you can retrieve a directory list of information in an EC2 instance with the IMDS configured by running the following command from the inside instance. So if you have done the room of EC2 instance, then you know what this does. This will give you all the information about that specific EC2 instance. Running this command inside EC2 instance with IMDS configured should return a directory listing with the various configurations data that may be of interest. That seems relatively harmless, right? Well, okay, let's also talk about server-side request forgery or SSRF. Until the cloud, SSRF was considered low-impact vulnerability under almost all circumstances. Maybe it would occasionally be a medium moderate impact vulnerability. Well, the cloud and the IMDS changed all of that. AWS isn't the only cloud provider that have an IMDS. Almost all cloud providers offer some sort of IMDS to their customers on both virtual machines like AWS EC2 and container like AWS ECS. Now back to SSRFs. An SSRF is a type of web application vulnerability where an attacker can manipulate the functionality of a server-side application to perform unauthorized actions on behalf of the application or the server itself. For instance, an attacker can supply or modify a URL or IP address and make a request that seems like it's from the server rather than the attacker. Why this can be handy if you need to proxy off your traffic. The implications seem pretty minor, right? Well, in 2019, a breach at Capital One changed the way we look at the IMDS and SSRFs. It turns out that if you can take a web request to an EC2 instance with an IMDS configured and have it return the resulting response, you can get some pretty interesting information from it. You will want to log into the attack logs or your associated AWS Cloud Shell to continue. Let's take a look. First, you need to find the public web server that Adam from Best Cloud Company left out there. He was experimenting with Python Flask web server and forgot to delete the project. He's not much of a programmer, but it's just always important to let people learn. Of course, he shouldn't have left it on the internet, but at the Best Cloud Company, we expect nothing less. You can find the public IP address by running the following command in your AWS CLI. So I have already configured my AWS account on this terminal. I don't have to do it anymore. But in your case, make sure that you sign in. Either you can use the Cloud Shell right here, or you can use the AWS terminal, whichever you prefer. And let's try this. So this is going to be the command that we use. CloudFormation describe the stacks queries, and then we're going to get the stack name, which will contain the public IP address. Cool. Let's copy it. Put it here. And now what's the IP address that we have? Okay, description server's public IP address. Let's take a look at it. Copy and can we do it here? Yeah, we can. Alright, this command will allow you to retrieve the public IP address from Adam's Flask experiment. Once you have the public IP address for the Flask server, you should be able to travel to the Flask server homepage where you will see something similar to this. Okay, we saw that. Now, you get to perform an SSRF to steal credentials from an instance hosting this Flask server. This is possible because AWS EC2 instances commonly have that what is known as the instant profile. The instant profile is a constantly refreshing AWS role that runs on EC2 instance. When a machine has been configured with an instant profile, you can retrieve the profile credentials from the metadata endpoint. Since this concept is somewhat advanced and we are attempting to make it a sufficiently simple demonstration, we will have created a web server that is intentionally and obviously vulnerable to SSRF. In fact, it takes an URL as form of input from the user and returns the web page information. This is simplified for demonstration purposes. And if you want to learn more about a practical SSRF attack, please take the Join Hack Me room on SSRF. Okay, I'll check that later. I'll just leave it here. Okay, to perform the SSRF attack, you can enter the following URL in the input form of the Flask server. Okay. Let's try that. HTTP. Again, I'm gonna type it out. Do we have curl? No, we don't have curl. Okay. HTTP 169.254.169.254 dot and then /latest/metadata /IAM security credentials. Now, if you don't know what this command does or what this URL does, I would recommend you check out the attacking EC2 instances room, which will give you a full understanding of these commands. Okay, so we've got Stacksets IAM initial. Okay, that's the return. Moving on. This URL is the metadata endpoint for retrieving an instant profile credentials. Yes, we saw that. Once you submit a form, the server will make a request to this URL on your behalf, and you should see the name of the instant profile role as the response. Next, you will need to retrieve the actual credential associated with that role. To do this, append the role name to the previous URL and submit it in the input form. So we have already submitted this one, right? So now, in order to get the credentials of this specific role, we only need to append this one, the role name, at the end of it, which is supposed to be like this. Copy paste, not this one. Let's try one more time, and we should get the credentials of the profile. Pretty scary, huh? Yes. We have the access key ID, we have the secret key IDs, we also have the session token. This is the STS. If you remember, it's service token security. No, it's security token service, my bad. Okay. Replace the role name with the actual role name you retrieved from the previous steps. When you submit this form, the server will make a request to this URL and return an instant profile credentials as a JSON object containing the access key. Here we go. Access key, secret access key, yes, and the session token right here. Now that you have the credentials, you can use them with the AWS CLI to perform actions on behalf of the EC2 instance. To do this, you need to configure the AWS CLI with these temporary credentials. Run the following commands and replace the placeholder with the actual values from the JSON object. So we try to log in. We try to authenticate as this role using this set of credentials. Copy, export, AWS access key ID. Oh, we can use another one. What profile is used? Yes. AWS configure set AWS access key ID, and then paste the value of the access key, and then specify a profile. Try hack me. Let's do it. AWS configure set AWS secret access key. No, we're missing one key, and we copy the secret key, which is right here. Copy and paste. Also specify the profile name, which is try me. And last but not least, AWS configure set AWS section token I'm just gonna be putting this one first before copying the section values because it's a long string. Profile try hack me. No. What was it? Should be this one all the way here. Copy. Paste. Okay, with these credentials configured, you can now use the AWS CLI to perform actions allowed by the instance profile name. Okay, clear AWS SDS get caller identity profile try hack me. Boom. Okay, so we have assumed the role Stacksets IAM initial access. Blah 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 blah. So that's how you compromise an EC2 using SSRF on the application. Pretty scary, huh? Yeah, I know. I'm scared now too. As long as you have the valid set of AWS credentials, yes, we did. So remember, this is a demonstration, and real-world SSRF attacks might not be straightforward. But however, the core concept remains the same: exploiting the server-side functionality to access sensitive information or perform unauthorized actions. By understanding how these attacks work and potential risks involved, you can better protect your AWS infrastructures and applications from similar threats. So what's the mitigations? Again, you have to use the IMDS version 2, which require you to use a token or which requires you to authenticate before retrieving any information. That's one way to mitigate this attack, and then the other way is to patch the vulnerability SSRF on the server side. Make sure that the vulnerability is fixed and the attacker can't exploit this kind of vulnerability on the application on the front end. Okay, what's the IP address of the Come on. What is an IAM roll call that is automatically loaded on the EC2 instance? Huh? What? Assume role? No. What is an IAM roll call that is automatically loaded on an EC2 instance? Is this? No, it's not this one. Okay, let's skip this one first. What are the first four words in the name of the assumed role? What are the first four words in the name of the assumed role when you retrieve the permissions from the IAM role? What? Stacksets IAM initial access. Stacksets IAM initial access. Okay. What is an IAM role call that is automatically loaded on the EC2 instance? Was it this one? Okay, when we run this one, we have the output value Stacksets. Nothing. I don't get it. What does it mean this one? What is going on? Let me try. Yeah, for some reason the virtual machine is very unstable for now. Wait a minute. Everything refreshes. Okay, this is number. Submit. This is initial access. Huh? It's wrong. Oh, what is the IP address of the AWS metadata? Okay, 169.254.169.254. Yes. What is an IAM roll call? That's automatic loading on the EC2 instance. What is it? Run this one, but without the security credentials. Okay, we can try AWS IAM get roles profile try hack me. Oh, list row, my bad. AWS IAM list roles and then profile. I'm not able to do it. Okay. AWS IAM list roles. Okay. You know what? Let's try this one first. AWS EC2. Well, the thing is, like, I don't understand what the question. I don't really understand what it means. So, AWS EC2 describe instances. Okay, we have the instant ID, we have the key monitoring, private ad, name stable, lock, okay. And IAM instant profiles. Instant profile. Okay. Okay, so I know, I get it. The question should be addressing this. The answer to the question was here or somewhere. Right here. Now you get two profile asset. This is possible because AWS EC2 instances commonly have what is known as the instant profiles. The instant profile is a constantly refreshing AWS role that runs on EC2 instance. When a machine has been configured with an instant profile, you can retrieve the profile credentials. So yeah, they were referring to the instance profile. Okay, now I get the question. What the question is? Yeah, sometimes the questions are a little bit confusing to me. Moving on. Scenario number 4, abusing DevOps infrastructures. The best cloud company folks are at it again. They can't seem to build security resources no matter what. Today, we have found a way to compromise an AWS Lambda function hosted behind one of their buckets. It turns out, if you can upload a file to their S3 bucket with a malicious file name such as do something malicious in Python, then it might execute whatever Python commands you upload and return the results in the response. This is because they use a Python method known as eval function to execute insecure user input in the form of the file name. Let's take a look at how we might exploit this security issue. First, you need to identify the S3 bucket associated with the best cloud company account. The bucket will take the form of account ID -2. Now, once you have found the bucket, verify that it is empty. Okay, AWS S3 LS. Okay. This is okay. And we run AWS S3LS and copy and paste this one. Yep, we have verified that this bucket is empty. Your first command lists the first command, which is this one, AWS S3LS, lists the S3 buckets in the account, and your second command, which is this one, AWS S3LS, and then the bucket's name, lists the objects in the bucket root. If there are no objects, it returns an empty line. As you can see, there are no objects in this bucket. Let's make an object and see what happens when we upload the object. Make a file name test.txt and add a line of the text to the file. This is a test. Okay, echo this is a test, and then text cut text. Okay, now upload the bucket. AWS add 3 copy test.txt and then to the bucket S3 bucket name right here. What? Oops. AWS S3 copy test.s3. We just simply copy this one, the bucket name. Okay, we can now verify that the file has been uploaded. ls Yep, it's here. You see there's also a log file right here. So let's download it and see what it is. AWS S3 copy S3. Oh my god. Slash and then this one. Log right here, copy Ctrl V over here. Now we have the log cat. The original template was the text.log. The original template contents were this is a test. Okay. Now when let's go back to the reading. Now when you request bucket, you should see the file, your file. Okay, we saw the file right here, the file we uploaded. We also saw the log file. There looks to be another file in your bucket. Is it possible that S3 bucket upload triggers something happen in the background and there's another file because of it? Yes, it turns out that AWS supports standard integration between services such as S3 and the Lambda function service. S3 upload can be used to trigger code to run in AWS Lambda. In this case, the code uploads a new log file with the same name. Okay, so right here, test.text.log, right here. Could they really have built automation that loads a file and then evaluates it, and return a log file? Could they really have been so idiotic? Yes, that's right. It's the best cloud company, only the best and the brightest. Today, it is generally accepted that you don't run the Python eval function method on unsanitized user input. Why is that, you ask? Well, the eval method takes in a string, like a file name, and evaluates it as a Python expression. Well, why does that matter for our S3 upload? These sort of automations are commonly slapped together in a piecemeal fashion by the DevOps and Site Reliability Engineer, or SRE, teams at organizations around the world. They're just looking to reduce the engineering toil of repetitive tasks such as continuous integrations, continuous delivery, CI/CD. However, individuals in these roles may have a limited development background and who may be unfamiliar with insecure coding practices. In this case, best cloud company's Python Lambda function is vulnerable to command injection. How, may you ask? Well, the function is evaluating the file name from your upload before returning the newly created file as the .log file. That means that you can run code inside that Lambda function. So what it means is right here, the name of the file is test.text, right? And the output log is going to be the test.text.log. So that's what it means right here, and we can leverage this to actually inject some commands into the functions and have the Lambda functions executed. Why AWS Lambda doesn't utilize an IMDS? There's a kind of Lambda request context, which is the information related to the execution environment where the serverless function runs in AWS. Similar to EC2 Instant Profile, you can also provision a Lambda execution role. This execution role gives Lambda function permissions in AWS against AWS services based on the permissions provisioned to the role. Sometimes these permissions may use least privilege and not be very useful for attackers, but often these are checkpoints. These are a checkpoint of excessive permissions. Now, how are we going to get the credentials, you might ask? We can retrieve the credentials using a little Python script we've provided. Okay, so let's try that script. Nano upload.py, and just copy and paste this one. Cut. Okay, if you take a look at this file before uploading and running it, what's happening? You can see the script is asking the user running the script if they have a specific AWS profile they want to use. If not, it uses the default profile. It starts a Bodo 3 section and client for S3 and S3 resources, where Bodo 3 is the AWS Software Development Kit, or SDK for Python. These clients allow the script to query the S3 service and specific S3 resources and declare the bucket we are targeting in our attack. Then, here's where the magic happens. We upload or put the object in Python script, an object to the S3 bucket. The file name is dictionary, and then in the parentheses there os.environment, which just so happen to be how you return the environment variables in a given Lambda environment that is running Python. Using the OS Python module, in this case, the Lambda function has already imported the OS module, so it isn't necessary. But even if it weren't already imported, import OS and then you run the command, should get the job done as OS is part of the Python standard library. Now you can run the script. Python 3 upload. What? Python 3.9. Okay. pip3 install model 3. Python 3 upload. Please enter your AWS current profile. Once you run the script, you should see the file name and timestamp of file printed to the console. You may want to download the timestamp to URL. Wait a minute. Once you have run the script, you should see the file name and timestamp file. I got the error. What happened? Python 3 upload. Does it work? Okay, it looks like there were some errors. Let's see what's going on. So enter your profile. Is the profile okay? We pick profile in the user in the bucket. So we got a bucket name, the file name. Okay, so let's see. The file name is so nano OS dot environment. Okay. So what is it inside the Python script? Addition, create object. Okay, upload empty files with malicious file name. Okay, so the file is empty. I just put a space right there. Shouldn't matter at all. Nano. Wait, LS. Do we have that file? Yeah, we have this one. Cool. Let's say upload that S3 copy dictionary to the S3 bucket. Okay, AWS S3 LS. So we had this one, the 143.303. So we got this one. We have these two. Okay, AWS S3 copy, S3 paste, and then this one. Paste. Now let's see, take a look at this one too. We have two log files. Copy. So we have 3 log files. Let's cut the 2024. Let's see the content of this one first. 2510. '07. Okay, we got the environment variables. Look at this. AWS region US1 PW var slash task. The index, okay, looking for the secret access key right here. AWS secret access key. Copy. Access key. Okay, lambda login group name. Okay, this is the group name. This is the lambda function's memory. Okay. Where is the access key? Okay, this is the token. Ooh, okay, juicy. Token goes all the way here, and then we also have the root. AWS default region is US is 101 login stream right here. Python latest regions. AWS secret keys right here. I don't see that. Oh, access keys right here. Okay, so we have access key IDs. We have secret key IDs. We also got sections. So basically, we were able to extract the environment variables on the lambda the environments that lambda function was running in, which provides us with the AWS credential used to run that lambda function. Yay! Okay, if you take a look at okay, we can't run it, so we don't really know how it turns out on the local machine, but we know what it turns out when you ran that in the AWS environment. So that's cool. Let's continue here, and there you have it. Your very own lambda execution role credentials. Can you figure it out? Yes. Once again, Mass Cloud Company isn't sanitizing user input properly and is allowing you to make arbitrary requests against the lambda function. While this is simple example will hopefully be uncommon in the real world, the complexity of the serverless applications mean that there are a large number of mechanisms for gaining initial access. In fact, here's an example of a moderately complex serverless application using AWS Lambda. Okay, we got the guy. We got a ton of services. We're not going to dig into this one. At this point, many attackers would want to put some sort of implant or get some sort of shells on the lambda function, but a lambda function only lasts 15 minutes, so it's not worth it. Whereas the roles credential you retrieve may last such longer, or depending on the configuration, may be able to be refreshed. Furthermore, these IAM credentials really form the core of what you are after in AWS environments, where domain administrator or DA is equated to administrator access privileges in a particular AWS account. Or better yet, administrator access across AWS account. Stay tuned for the IAM privilege escalation room, where we'll learn about the topic, which we haven't got it yet. Try at me, please. Get it out soon. Answer the questions. Once you have assumed the role with the stolen credentials, what two words from the role name fits the answer? Okay, so now we have to sign in. Okay, so we have secret access key. We have the access keys right here. and we got a token. Oh, no way from here. Boom, 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 boom. To here. Copy. Token equals this one. Okay, let's try sign in. AWS configure set AWS access key, set it to this one. And profile lambda AWS configure set AWS secret access key, copy the value, paste it here, and then specify the profile name, which is lambda. Last but not least, the token AWS configure set AWS section token. As usual, I'll specify the profile name first. Paste. AWS SDS get caller identity profile lambda. I guess the issue was right here. Go to spaces. Okay. Let's try again. LS. It's going to be this long. Cut. Paste. Grab. AWS. Access. Key. ID. Got this one. Copy. Paste. Okay. Same thing. AWS. Secret access key. We've got this one. Copy. Paste. Alright, and then finally the token, section token. Just want to make sure it stops at I stop at the correct place, and it has to be the one. Copy, paste. Alright. Now let's make sure that I configure the profile correctly. I'll go back here. Scenario number 3, and make sure that the command I run is correct. AWS configure set AWS access key ID. I forgot that access key. Profile. Let's say something else. Scenario 4. Let's say S4. Okay. AWS configure set AWS secret access key. And lastly, we set a session token, AWS configure, set AWS session, token. AWS SAS get caller identity profile S4. Yes, we got it. Thanks God. Thank God. Thank God. Right. Once you have the assumed role, what two-word string from the role name fits the answer? Simple lambda. And that's it for the room. We've learned 4 scenarios on how we can leverage IAM principle to get initial access to cloud environments. And these are pretty common techniques that attackers use that we should be aware of when it comes to defending AWS infrastructure. We should be knowing that what we are dealing with and constantly getting updates with the news, because nowadays attackers are trying to be smarter. Even though we have some security implemented and improved, there's still a lot of vulnerabilities, especially in a large-scale application where many microservices or serverless services are used. So that's it for today's room. I hope you enjoyed the room, and if you have any questions, again, please feel free to reach out to me. I'll be happy to help you. All right. Until next time, then. See you. Bye.